Buried deep under the medical school library at Yale University are hundreds of brain specimens, floating or sunk into jars of formaldehyde like a scene straight out of a horror movie. The brains have been chilling down there for over half a century now, leftovers from experiments done by Dr. Harvey Cushing, one of the first neurosurgeons and a father of endocrinology. And this dude went through a lot of brains. You see, Cushing lived during a weird transition time in medicine. We were about to figure out that how the body talked to itself was way more complex than we first thought. If you watched the last episode in this series, then you remember what happened before we discovered hormones. We knew that glands in the body could secrete different substances that did something, but we really didn't know much else about them. Before the discovery of hormones, we thought that the nervous system took care of all that within-body communication stuff. An organ connected to a nerve, which sent that message to the brain. And that made sense for the time. If you were lucky enough to see a human cadaver or just look at a medical chart, then you can clearly see nerves all connecting back to the spinal cord, which runs at the brain. And we've known the brain is important for like forever. And that's ultimately why Cushing's brain collection was so important. See, Harvey Cushing was a neurosurgeon, and like a dope neurosurgeon at that. Can you even imagine getting a brain tumor removed during the same time as World War I? Yeah, no thanks. There was a really good chance you wouldn't survive the surgery, like greater than 50% even in some industrialized cities. But Cushing's post-op mortality rate was only 8%. I mean, the cancer usually killed you if you survived the surgery, so Cushing's post-op mortality rate was low because yes, he was a very precise surgeon, but he also used some different methods of accessing the brain than his colleagues did. And it was exactly this type of skill which allowed him access to a really hard to reach organ, the pituitary gland. Now, by contrast, most endocrine glands are pretty easy access. The thyroid is hanging out under a little bit of skin in your neck, the adrenal glands sit on top of your kidneys in your back, and your testes are just like there. But the pituitary is a tiny gland tucked away in your brain. Like if you picked your nose and just kept digging in real far, you'd tickle the pituitary. When you struck gold, you'd notice two tiny lobes, the anterior and the posterior. And while they're small in size, they're extremely important for your endocrine system. Cushing was by no means the first to identify the pituitary, right? Doctors back in the 1740s knew that it could secrete chemicals into the blood, but by the time of Cushing, they had connected its dysfunction to a condition called acromegaly, a disease where certain body parts enlarge. And since it could make bodies painfully big, a surgeon named Bernard Ochsner decided to take it out of certain developing animals and saw that sure enough, removing the pituitary would keep the animals small. So our dude Harvey Cushing stepped in. He used that neurosurgical skill to perform some experiments of his own. But unlike scientists who came before him, he separated the two lobes. One of his first observations was that his dogs would die if he removed the anterior lobe, but they would survive if he took out only the posterior. Or if he fed the posterior pituitary to dogs, he saw swollen kidneys and increased blood pressure, but what looked like malnourishment when he fed them anterior pituitary. So there was a difference between the two. My favorite of his experiments though, was when he took cattle pituitary and fed it to human dwarves, hoping that they'd grow. Needless to say, they didn't. So he kept experimenting. And by experimenting, I mean finding corpses and looking for weird skulls. He even went as far as paying a mortician to allow him access to one of his previous patients' brains. Dubious, yes, but sometimes the law gets in the way of good science, you know? If only they had MRIs or CT scans back then. Oh, wait, we're not dealing with a regular neurosurgeon, we're dealing with Harvey Cushing. Harvey, whatever your middle name was, Cushing. He and his team used the fancy new technology that they did have access to, the newly invented X-ray. This part's wild. He and his team noticed that certain bones in the skull would look a little bit different depending on if there was a tumor or if certain glands around it were enlarged or shrunken. They used clues about the body that they could only see because of this new imaging technology to infer information that really wasn't obvious. Dude, sorry I'm gushing, but this is just one of my favorite examples of how in science, it's not enough just to be smart, you have to be creative too. So with this new X-ray technology in his tool belt, he didn't have to cut anybody open to see where that swollen pituitary or those deformed bones were. And Cushing was especially interested in those swollen pituitaries. His observational powers took off after that. When he saw those pathological pituitaries, he usually found other problems in the body as well. After doing some of those experiments in years prior, he was starting to get the idea that the pituitary didn't have just one function, but it acted like a control center to kick off other glands in the endocrine system. And it was probably involved in growth somehow too. So Cushing became an expert on the most important gland in the endocrine system at a time when studying hormones was more popular than ever. But here's the thing. The more you learn about anything, the more you become aware of how much you don't know about that thing. So by identifying the pituitary as important, it begged for more research. By that time, multiple other doctors were studying the pituitary, like Alfred Froelich, who put together a case study on a 16-year-old boy with a pituitary tumor who, along with becoming sluggish and fat, also didn't develop sexually. While the disease would get named after him as Froelich syndrome, he called it asexual adiposity. Adiposity just referring to the fat gain, and asexual referring to the lack of sexual development. Not like the modern day sexual orientation. Okay, so knowing a bit about Froelich's case study, Cushing was primed for one of his animal experiments. He took a dog that had its pituitary removed and noticed that it was becoming fat, sluggish, and losing its sexual interest. It sounded exactly like Froelich's boy from a few years earlier. But wait, didn't pituitary problems cause excessive growth like in those acromegaly patients? That's where Cushing's creativity comes in again. He coined the terms hyperpituitarism and hypopituitarism. Hyper for too much, hypo for too little. We could no longer think of hormones like a button you push to create good health. It was more like a balancing game. Too much pituitary secretion early on and your baby becomes a giant. Too little pituitary secretion after puberty and that fat, sluggish, low sex drive profile takes over. Now, it would still be a few decades before scientists isolated the key player here, growth hormone. But there were still so many unanswered questions. All right, unfortunately, not every disease could be attributed to either too little or too much secretion. Like a few years later, researchers also saw that removing the pituitary led to shrunken adrenal cortices, those glands right above the kidneys. But the most important question that we could ask is how does this gland control so many other glands? Doctors kept studying pituitary function for years to come. But dude, once growth hormone gets brought into it, the story gets good. But at the time, they still had a lot to learn about the endocrine system in general. Remember, we had just come off of that whole old school nerves control everything inside of me kind of thinking. It was clear that this anatomy was built to take a message from brain to body and do it quickly and efficiently. But if the nervous system did its job so well, why do we have hormones? Well, because bodies don't just exist by themselves. They exist in an environment. The nervous system has the job of taking stimuli from the environment and interpreting it, whether we fight, run, do something else. So if the nervous system did that, did hormones have any cool tricks for playing with the outside world too? Well, in that question is where the difference becomes pretty obvious. The reason the endocrine system exists is to maintain homeostasis, a nice stable physiological environment, right? Not too hot, not too cold. Just right. Okay, it's more than just temperature. Your body has a bunch of feedback loops that keep things in check. For example, say you eat a big meal, you digest it, and it breaks down into glucose. That increase in blood glucose is detected, and your pancreas is stimulated to release insulin, which kicks your cells to take up some of that blood glucose. As blood glucose drops, the pancreas releases glucagon, which promotes the breakdown of glycogen, which raises blood sugar, which gets the pancreas to release insulin, and the cycle continues. Without any kind of feedback, hormones would be under or over secreted, which is exactly what we saw in Cushing's experiments. Oh yeah, whatever happened to him? He enjoyed a long career within neurosurgery, wrote some books, and left his collection of brain specimens to Yale University for us to be perpetually creeped out by. Speaking of being creeped out, the next episode will take a deep dive into the history of puberty. Let's get ready to get uncomfortable. Thanks for watching episode 2 in the hormone series. If you liked it, would you mind sharing it with a friend? That's the best way that you can help support this channel. Otherwise, subscribe if you haven't already, like the video, drop us a comment, say what's up, and have fun, be good. I'll see you next time.